All right, I am going to spend some time talking about the back of the sheet of paper that is your homework tonight. So your homework tonight is problem number 1. I am showing you how to do problem number 2, which is very similar to problem number 1. Okay? All right, so the first thing we need to do is we need to plot this data in a grid. And so my x value is my number of family members. And then the y value is the number of cars. All right, so if x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 1. When x is 5, y is 2. When x is 6, y is 3. When x is 7, y is 1. When x is 8, y is 2. When x is 9, y is 3. When x is 10, y is 8. Okay? So looking here, part B, it says to describe the correlation of the scatter plot. And correlation means, are all the dots kind of going up together, or all the dots kind of going down together? And if they're all kind of going up together, that's positive correlation. If they're all going down together, that's negative correlation. Well, these dots do not seem to have any sort of pattern. So I'm going to say that there is no correlation here. Oops. Correlation. Okay, now the residual plot, we're not there yet. We can't do that. We'll come back up to that. That was just here because that's where it fit on the paper, okay? That doesn't mean we necessarily have to do it now, okay? So we did A, we plotted. Now we're going to do, we did B. So now we're going to do C. So C says use eyeballing to estimate the best fit line of your data. Draw it on your graph and write the equation below. Well, this is going to be a challenge here because since there does not appear to be a correlation here, it's going to be very hard to draw like an oval around our data, but we're going to try and we'll see what we come up with. Okay, so this is kind of, I guess, where it would go. Okay, and you want it to go through the middle of the data, so we're going to see if it goes like that. I don't know, I guess that's kind of middle. Maybe it should go up a little bit more. Yeah, that looks a little bit better. Okay, so when we want to find the equation for our line, we want to find 2 points that are on the line or that are very close to the line. This is kind of tricky here because these points do not seem to, they're all mostly underneath the line. But we're going to pick 2 points, and this is actually a good example to show you that there isn't always a relationship between the 2 points. They're the 2 sets of data. All right, so the way we find the line of best fit, so we're finding the equation for, and I know that this is not matched on perfectly, but for this blue line right here, because I've decided that based on this data that this is the line of best fit for the data, okay? So the way I find the line is I'm going to do y1 minus y2, and these are my points. And so this point is 2, 2, and this point here is 1, 1. So when I do difference of my y's, which is going to be 2 minus 1, over difference of my x's, which is 2 minus 1, I get 1 over 1, which is 1. So this means that the slope is 1. Well, remember, this is a linear line, so it's going to be written y equals mx plus b. So to find the equation for that line, I'm going to pick a point. It doesn't matter which one, I'll just pick that one. And I'm going to plug 1 in for my y, 1 in for my x, and we've already decided that m is equal to 1. So 1 is equal to 1 times 1 plus b. 1 is equal to 1 plus b, subtract 1, and you get that b is equal to 0. So because I know my slope and I know my y-intercept, I know the equation of this line is y is equal to 1x, which is just x, and then plus b, which is 0. Now, based on this equation, because x stands for the number of family members and y stands for the number of cars, this means however many family members I have in my family, that's the number of cars that we're going to have. Now, as you can tell, that's not always the case. If you have 6, is the 6 up here? No. So we can already tell that this isn't really a good line of best fit. But we're going to keep going with it just to kind of show you mathematically why we know. Okay. All right. So then the next thing says to find the least squares. Remember, this is your linear regression line. That was a We needed to fix that. So we're going to use the calculator to find that. So what we're going to do is we're going to enter value, and again, you need one of the school calculators or one of your own to do this. This is your L1 data, and this is your L2 data, because this is your X values, and these are your Y values. So I'm going to enter my data, and the way I do that is I hit data, and if you have to clear it out, you're going to have to hit data twice to clear out each of the lists, L1 and L2. So in L1, I'm going to enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's pretty easy. And then in list 2, I'm going to enter 1, 2, 3, 1, 2, 3, 1, 2, 3, 8. Now to do the to find the equation for the line, you hit the green second button and you hit data. Because there's two variables entered here, we're going to scroll down and highlight the 2 for two variable stats and hit enter. Make sure your calculator is set so that the X value is L1 and the Y value is L2, and go down to highlight calc and hit enter. Now on here you're going to have all sorts of numbers, but the ones that you care about, it's going to be the lowercase a. And again, I said lowercase a, not capital A. Keep going down until you see a lowercase a. And in this calculator, you should see, and I know I don't have a lot of room here. In your calculator, you should see that it says a lowercase a is 0.4, lowercase b is 0.4, and so when I write my equation, this a, this stands for my slope, and this is my y-intercept. So when I'm writing my equation, that means that y is equal to 0.4x plus 0.4. Because this is the calculator's calculation of the line of best fit, which is more accurate than ours, it's called linear regression line. Okay, so the linear regression line is the calculator's version of the line of best fit. Now, the correlation coefficient given in the calculator, it's right underneath where it said A and B in the calculator. The next thing down is 0.59. Again, we're rounding it to the nearest hundredth place. Okay. Now, excuse me. Your correlation coefficient, your R, is some value between -1 and +1. The closer it is to -1, the stronger the negative correlation there is, because -1, think of a slope of -1, it's going to be going down like this. If it's close to 0, sorry. If it's close to 0, that means that there is no correlation between the numbers. And if it's close to +1, that means there's a strong correlation. If it's not really close to 1, like this right here, 0.59, I'm going to say that that is a weak positive correlation. Okay? And I did correlations again. Sorry. Okay, now it says to interpret the slope of the regression line in context. That means this is the slope here, okay? And X stands for the number of cars. So that means that for every person in your family, for every one that we multiply here, the number of cars increases by 0.4. Okay? For every person that we put in here, my number of cars is going to increase by 0.4, or 0.4. The y-intercept, which is 0.4, says that even like starting with 0, you're going to start off with 0.4 cars. So can you have part of a car? No, but just for this, for sake of this scenario, okay? So you're going to you're starting off with 0.4 cars. Now the residual, okay? The residual here is the difference between, remember, the residual tells us how accurate our line of best fit is, like how good it measures. So how good in this case does the 0.4x plus 0.4 work? And let me actually, I know I'm not going to really have a lot of room here, but if my y-intercept is 0.4, which is like was like right here, and I'm going up 0.4x every 1, my line of best fit really needed to be something, and I know this is not accurate, but it needed to be really more right there, okay? So this is what the actual line should look like, okay? And so when I look at this and I'm thinking about the residual, I want to decide, okay, this is the calculator's line of best fit in green. So the residual, I'm going to calculate the residual, and the residual is going to tell me whether or not this is actually a good line of best fit. So residual is the difference, and I know that this isn't what it says here, but I'm going to have to I'm going to have to subtract here. So sorry, I'm having to go back and forth. So when x is 1, we had that y was 1. This is what was given. And so and this was 2 and 3, and then it kind of went over again 1, 2, 3, and then it went 1, 2, 3, and then 8. All right, so residual is you're going to have to actually calculate the values of, I wish this table wasn't here. I'm sorry, this table is a bad table. Let me, okay, sorry I'm doing this, but I want to make sure that, all right, so we have our x value, we have our y value. So our x values were 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then our y values were 1, 2, 3, 1, 2, 3, 1, 2, 3, 8. Okay, so let me, okay. Sorry, I just didn't like the chart that was on that paper. Okay.